Welcome folks. Before us we have a question in physics under moment, and we can define moment as the ability of a force to make an object turn. Now, moment is used in everyday life activity. For example, opening and closing of a window, a door, moment is there. If you look at pushing a wheelbarrow, moment is there. Tightening and untightening of a nut, moment is there. Seesaw, when children are playing on a seesaw, moment is there. So now in this video we are going to look at the moment, how to determine if the two moments balances and cancel each, then also how to look at how do we calculate moment plus the units. So the question reads, figure B2.1 shows a device designed to compress crush material for school science project. So now under moment, it's important we identify the two moments that we have. So the first moment, we are going to look at the clockwise moment. So the clockwise moment, as we can see, we are looking at the moment in the direction according to the clock. So this is the moment that goes in this direction. Then the second moment is the counterclockwise moment. So counterclockwise moment, we are looking at now the moment that goes in the opposite direction. So for this one, we are looking at the moment that must go in this direction, right? Then after we've done this, let's begin by first identify where the pivot is. The pivot is a very important point because it's a point where the moment, the turning of the moment is done. So this is where our pivot is. Then after we've identified the pivot, we can now look at the point of action. So the point of action is a point where the force is applied, and remember the force must be applied perpendicular to the distance, right? Now let's analyze our given figure B2.1 here. So how can we identify the two moments? Because sometimes this question may seem to be tricky. So where are those two moments? So it's easy to identify the first moment. So this is our first moment, which is the clockwise moment. But where is that counterclockwise moment? Where is it? Now, if you look at this lever beam, there is a 50 newtons. There is a 50 newtons applied here. So this 50 newtons is pulling the lever down. So as the lever is being pulled down, it is forcing this metal support to apply a force on the piston. Now since here we have the material that we are trying to crush, so there are materials that we are trying to crush here, there will be a force from the piston which is coming from the metal support that will push the material closer to each other. So as the materials are coming closer to each other, then they are being crushed. Now there is a point where if a certain amount of force applied for clockwise moment is not that much strong, this piston will not move down. So whenever if the piston is not moving down, it simply means that the force applied by the material that you are trying to crush, the moment that is pushing up here is equal to the moment that is pushing down. So for this case, then we are expecting to have an equilibrium point. So this is what we call an equilibrium point. So to summarize our answer, we are saying the counterclockwise moment is produced by the material that we are trying to crush. Now to answer the first question is about set one condition necessary for a body to maintain equilibrium. So for this body to maintain equilibrium, the clockwise moment must be equal to the counterclockwise moment. So say clockwise moment must equal the counterclockwise moment. So that is our point here. Now, away from there, let's look at the question. So the question is B, calculate the moment of the 50 newtons force about the hinge. So remember, the hinge is just the pivot. So the moment that we are asked to find at question B is the moment produced by the 50 newtons here. Now, let's look at the formula that we can use to calculate moment. So I'm going to draw a triangle that might be of help to someone. So under this triangle, I'm going to put capital letter M on top. So this is the moment. And the symbol that we use for moment is capital letter M. Then I'm going to put F for force. So the force must be newtons. Then I'm going to put small letter D. So this is for distance. And whenever you're calculating moment, you need to make sure that the distance is given in meters. So in our case, we can see that we have been given the distance in centimeters. So we are going to change into meters. Now, if we are solving for moment, we can see that we are going to multiply force times the distance. If this is the case, then what are the units for moment? So moment is measured in Newton meters, and please never confuse. Do not say Newton per meter. This is different from this one. So the correct unit for moment should be Newton meter, because the force is multiplied by the distance. Now, after this is done, we can now go back to our question. So we are saying moment must be given by force and the distance. The force is 50 newtons. So where there is F, we put 50 newtons multiplied by the distance. Now, how do you get the distance whenever you are dealing with calculations of moment? So always the distance must be measured from the pivot up to the point of contact. So the pivot is identified. Where is the point of contact for 50 newtons? So it is at this point, because this is where the force is applied. So this is our point of contact. So what is the distance in total from the pivot up to this point? So we are going to add 10 centimeters plus 55 centimeters. So this is the distance from there. So now the distance should not be in centimeters, so we need to convert. So 1 meter is equal to 100 centimeters. So to change from meters to centimeters, you multiply by 100, then the reverse, you divide by 100. So distance will be equal to 10 centimeters plus 55 centimeters, which is in total giving us 65 centimeters. So to change from centimeters into meters, we divide by 100, and this will give us 0.65 meters. So this is now the distance that we are going to put here, 0.65 meters. So we just have to do some math here. 50 multiplied by 0.65, then I'm getting 32.5 Newton meters. So this is our answer for this question. We move on to C. Calculate the upward force which the crushed material exerts on the piston to keep the beam in equilibrium. So for this to be in equilibrium, we said moment 1 must be equal to moment 2. So the moment is the force. So say force 1 times the distance 1 is equal to force 2 times the distance 2. Now, if you have been given the information like the distance for moment 1 and you want to use that to find for moment 2, for this one, even if we use the distance in centimeters, the answer will not be affected. What do I mean by this? So I go back to my diagram. So for moment, this moment, the distance will be 10 centimeters because we are looking at pivot and the point of action is, this is our point of action for the second moment. So the distance is 10 centimeters. So we're going to say we are solving for moment 1. So for this moment, force 1 we don't have. Then multiply by the distance 1, which is 10 centimeters. Then force 2 is 50 newtons. Multiplied by, I'm going to use now 65 centimeters. 10 centimeters times F1 is 10 centimeters F1. Then if you multiply 50 by 65, we can just write a 0 here. Then 5 times 5 is 25, so we write 5, we keep the 2. 5 times 6 is 30, plus the 2 will give us so it is 3,250 Newton centimeters. Then we divide by 10 centimeters, we divide by 10 centimeters, so that if I can cancel, I have F1 is equal to the centimeter will cancel this and will cancel, so I'm getting 325 newtons as our force 2. So whenever the force is 325 for the upward force, then our lever will be in equilibrium. Now let's say we convert the distance, we use the distance in meters. Can we get the same answer? Let's try. So we are still solving for force 1. Distance 1, we know that it's 10 centimeters. So if we divide by 100, this will give us 0.1. So we have 0.1 meters. Force 2 is 50 times 0.65 meters. So 0.1 meters times F1 is 0.1 meters F1. Then we calculated this one before, is 32.5 Newton meters. So if we divide by 0.1 meters, also 0.1 meters. So F1 is equal to, so we cancel the meters. So what is the 32.5 divided by 0.1? So according to my calculator, I'm getting 325 newtons. So it's the same answer. Now, can we prove that the moment is in equilibrium? So let's give it a try. So for us to prove, we have the force produced by the material that we are trying to crush. So this force is going upward and is 325 newtons. So let's find moment 1 separately. So moment 1 is equal to force times distance. So the force is distance. Okay, let me begin with the force. So the force is 325 newtons times the distance is 10. So this is 3,250 Newton centimeters. So let's not worry about centimeters. Let's find the other one. So the other one will be moment 2 is equal to force times distance. So the force is 50, the distance is 65. So if you multiply 50 by 65, I'm getting 3,250 Newton centimeters. So we can see that this number is equal to this number. So the moment going upward is 3,250 Newton centimeters. The moment going downward is 3,250. For this case, the lever is in equilibrium, and we can conclude that a moment 1 is equal to moment 2. And on this point now, the principle of moment is observed or is achieved. So the principle of moment states that for a body to remain in equilibrium, the sum of the clockwise moment must equal the sum of the anti-clockwise moment. So let's hope you've learned 1 or 2 on this question, and that's it for this video.